Now come to the next point, next method, that is Webster method. In this method, we introduced a optimum signal cycle time C0. In this method, we introduced a optimum signal cycle time C0 corresponding to least overall delay. Now, what is a C0? C0 equals to 1.5 L plus 5 1 minus Y. Now, what is the L and Y? Where L is the total lost time per cycle in second. Now L equals to 2n plus R. Now what is n and what is R? N is the number of phase and R is the rate amber time. And what is the Y? Y equals to, it is the ratio between normal flow to the saturation flow. So Y is the ratio between normal flow, which is denoted by Q, to the saturation flow, which is denoted by S. Now what is normal flow and what is saturation flow? Normal flow. Normal flow calculated during design hour or during peak 15 minutes. Normal flow calculated during design hour or during peak 15 minutes. And what is the saturation flow? It is calculated by note down the number of vehicle in stream of compact flow during green phase time. It is calculated by the number of vehicle in stream of compact flow during green phase time. Calculated by the number of vehicle in stream of compact flow during green phase time. Now green time. Green time formula is G equals to Y small y by capital Y into C0 minus L. Now small y means y1 plus y2 plus y3 dot dot summation of y, and y1 value will be q1 s1, y2 will be q2 s2, here it is y, it is the ratio between normal flow and saturation flow. Normal flow denoted by q and saturation flow denoted by s. Normal flow and saturation flow, and this value is the total summation of the normal flow to the saturation flow. Now come to a problem. For designing a two-phase fixed time type signal at an intersection having north-south and east-west road where only straight ahead traffic is permitted, the following data is available. Parameters are given: design hour flow and saturation flow. Design hour flow means Q and saturation flow means S. Value are at north and south direction 1000 and 700, and east and west direction 900, 550. The saturation flow value in north direction 250, south direction 250, east and west 300, 300. These two values are same for north and south direction, and for east and west direction these two values will be same. Now total time lost per cycle is 12 seconds. The cycle length in second as per Webster approach is. That means using Webster method. Webster method formula is written here: 1.5 L plus 5 1 minus y. Now given data is total lost time 12 seconds, the cycle length as per Webster's approach, C0 equals to 1.5 L plus 5 1 minus y. Now what is the value of y? L is given here 12 seconds, and y value, to determine the y equals to, we know that q1 by s1 plus q2 by s2, because there are two values are there, north and south direction and east west direction, both the same line. So we are taking the highest value of these two, and the same value, taken any one. 1000 by and 900 by 3000. Highest value is 1000 and east west direction, the highest value is 900 and these values 2500, 3000. So now come to the formula. C0 equals to 1.5 into 12 plus 5 divided by 1 minus 1000 by 2500 plus 900 by 3000. Solve this formula. Solve this. 23 0.3. The value will be 76.67 second. That means 77. Answer will be 77. Now come to the another problem. That is, a pre-timed 4-phase signal has critical lane flow rate for the first 3 phases as 200, 187 and 210 vehicle per hour with saturation flow rate of 1800 vehicle per hour per lane for all phases. The loss time is given as 4 seconds for each phase. For each phase, loss time for each phase 4 seconds. If the cycle length is 60 seconds, cycle length, that means C0, 60 seconds. Now using Webster method, C0 equals to 1.5 L plus 5, 1 plus Y. 60, 1.5 into 4, and for each phase, number of phase is 4. Number of phase is 4. So here we will be multiplying 4 phase. 4 phase, each phase 4 second. So 4 into 4 second plus 5 total phase time, total phase loss time, this 1 plus Q1 is 1 plus Q2 is 2. The value is 200, 187 and 210. With the saturation flows are same, 1800. Now to determine the fourth phase, there are 3 phases are there. The fourth phase should be calculated. Q3 is 3 plus Q4 is 4. The value comes 29, 1, oh sorry, really minus 1 minus 1 by S1, both all S1, S2, S3, S4 are same, so common this part. 200, Q1 value is given 200, Q2 187, Q4 210 and plus Q4. $597 plus Q4. By solving this equation, Q4 comes 333 vehicle per hour. Now what will be the effective green time? Our question is, what is the effective green time for the fourth phase? Now green time formula, time for fourth phase, G4 equals to Y4 divided by total Y into 60 minus 16. Y equals to Q1 is 1 plus Q2 is 2 plus Q3 is 3 plus Q4 is 4. 207, 210, 333. The value comes 516. Now Q4 is 4 divided by 0.516 into 44, and G4 will be 516 into 44, 15.77 second. So thanks for watching this video.